This is the Unit 6 Study Guide key. All right, number 1, determine whether the function graph below is invertible. All right, so to do this, we would test this graph using the horizontal line test. And since the horizontal line crosses the graph in 2 spots, this is not invertible. All right, it fails the horizontal line test as it crosses the graph in more than 1 point. All right, there you go. Number 2, which of these functions is not invertible? Explain 2 reasons why. Okay, we're supposed to use vocabulary words. The 2 that are important for this one is the horizontal line test and degree. All right. So the function that's not invertible is actually the second one, the g of x. And the reason why is because, number 1, even degreed power functions are not invertible. And number 2, if you were to graph this graph would fail the horizontal line test as it would go through more than 1 point. So that's it. So number 1, even degree functions are not invertible. And the reason being is because it would fail the horizontal line test. So x to the 4th looks a little bit like the graph that we just saw in number 1. It looks like a parabola type shape. Number 3, how can you determine without graphing whether a power function is vertible? Explain. Well, we just saw that in part 1 of question number 2. So even degree power functions are not invertible. There you go. All right, question 4. The function h of x equals x to the 4th, it is invertible, or is invertible if its domain is restricted. So this kind of breaks the rule of question 3, but we're cheating because we're restricting the domain to be x is greater than 0. Now, one thing we haven't looked at so far, but it's not a big deal, is the inverse. This is the sign for an inverse function, that -1 on the h. Okay, so to find an inverse, we've done this before. We just replace the x and the y, so it becomes x is equal to y to the 4th power. All right, and then we solve for y. We do the 4th root on both sides, so y is equal to the 4th root of x. This is your inverse. I don't care about the notation. If you leave it like y equals the 4th root of x, that's fine. Okay. Now for part B, we're going to actually skip part B and go to part C first. Okay. And I'll explain why in a moment. So it says sketch the graphs of h of x and h of prime of x, which is the inverse part, on the coordinate plane below. Label the graph of each function. All right, so I'm going to do h of x in blue. That's the first one, the x to the 4th. It's going to look like this. And the inverse, I'm going to do in red, it's going to look like this. Okay, so that's what the graphs will look like because they are restricting their domains. All right, now we're going to go back to part B, and we're going to reference the graphs as we do it. Okay, I'll first do h of x. The domains, the x values that exist in the blue graph. Well, it starts at 0 on the x-axis, and then it goes towards positive infinity to the right. For the range of the y-axis, it starts at 0, and it goes up towards positive infinity. For the inverse, the domain on the x-axis starts at 0 and goes to the right towards positive infinity. And the range starts at 0 on the y-axis and goes up towards positive infinity. So they're the same. And that's the domain and range. Next, number 5. Sketch the function k of x equals x to the third is invertible. Sketch the graph and the inverse of the graph. Okay, so I'm going to show you the inverse. It's pretty straightforward. It would be y is equal to the cube root of x. That's the inverse. Okay, so I'm going to sketch the first graph, k of x, which is x to the third in blue. It's going to look like this. Oops, sorry. And then I'm going to label it. So this is k of x. I'm going to do the other one in red. Oops. So that is going to look like this. This is k of x. All right, those are the two graphs. All right. Next, number 6. The function g of x equals x to the 6 is invertible if its domain is restricted. So this is a little bit like question number 4. Sketch the graph of g of x and g of prime of x with the domain restrictions. Okay, so if we're restricting its domain, it's x to the 6th. It's going to look like this. All right, that's the regular g of x. And I'll do the other one in red. So the g prime is going to look like this. All right, oh, forgot to label the first one. And there we go. That's what the graph should look like. Notice all the even degree functions, their graphs look pretty much similar. All right, so we saw that in part C of number 4 and question number 6. Now for these, we're going to keep the graphs up there. Domain and range of x to the third. Well, x to the third is the blue graph above in question number 5. The domain, the x values that exist are negative infinity to positive infinity. On the range, the y values that exist are the same, negative infinity to positive infinity. All right, consider the function f of x equals x to the 6. Now, it doesn't talk about domain restrictions in this particular case, in number 8, so I'm not going to use the same for the one that's been domain restricted above. Okay, so x to the 6, without domain restrictions, and since that's not listed in this problem, we're not going to have them, looks like this, with your x and your y-axis. Okay, so the domain of that would be negative infinity to positive infinity. And the range, the y values, would start at 0 and go up to positive infinity. All right. Now, if it had said that we restrict the domains, both of them would be 0 to positive infinity. All right, here we go. Question number 9. What is the first step when algebraically finding the inverse of a function? That is to switch the x and y terms. We're going to switch them around. All right, determine the equation for the inverse of the function g of x equals 6x plus 2. So we're going to switch out x and y, so x will equal 6y plus 2. Now we're going to solve for y. First step is to subtract 2 from both sides. So x minus 2 equals 6y. And the last step would be to divide both sides by 6. So y is equal to x minus 2 over 6. Number 11. Finding the inverse of this. Again, we're switching out x and y, so it's going to be x is equal to the 5th root of y minus 2 plus 1. Okay, the first step we have to do is subtract the 1 from both sides. So we have x minus 1 equals the 5th root of y minus 2. All right, we have to get the square root sign or the radical sign by itself before we can get rid of it. To get rid of it, we're going to raise both sides of our equation to the 5th power. So this would go away and that would go away. So we have x minus 1 to the 5th equals y minus 2. Now, unlike when we're solving radicals, we don't have to multiply x minus 1 to the 5th, by itself 5 times. That's not what we're doing. We're just finding the equation. The last step of this to solve for y would be to add 2 to both sides. So y is equal to x minus 1 quantity to the 5th power plus 2. That's your answer. Okay, number 12. Okay, so again, we're going to switch out x and y. So it's going to be x is equal to 7 over 2 y to the 3rd. Okay, before we can get rid of the exponent, we got to get rid of the 7 over 2. Okay, there's a couple ways you can do this. The easiest way would be to multiply by its reciprocal, 2 over 7. Then the 2's and the 7's cancel. So we'll get 2 over 7 times x equals y to the 3rd. Now that our exponent is by itself with the variable, we can cube root both sides. So we're going to have y is equal to the cube root of 2 over 7x. That's it. Number 13. Finding the inverse of this function. So we have x is equal to 2, the 4th root of x minus 3. Now before we can get rid of the radical sign, the root sign, we have to get rid of that 2 out in front. So we're going to divide both sides by 2. So x over 2, these would go away. 4th root of x minus 3. Now that the radical sign is by itself, we can raise both sides to the 4th power. So we have x over 2 to the 4th power. The radicals and the exponent go away. We have equals x minus 3. And the last step would be to add 3 to both sides. Oh, I made a mistake. Didn't catch it. You should all be wise. All right. So now I have y is equal to x over 2 to the 4th power plus 3. All right. Transformations. Describe the transformations. There's one transformation here. This is the only one. So our transformation is a vertical shift down 9. Part B. There's only one transformation. This is a horizontal shift. Since it's minus on the inside of the function, it's going to go to the right by 9. Part C. Again, we only have one transformation. Since we're adding on the outside, it's a vertical shift. It's going up by 3. And lastly, one transformation, we have a horizontal shift. Since it's plus on the inside, it's going left by 3. Okay, some more transformations. So what is going on in the transformations here? We have two transformations in this equation, this function. There's 1 and 2. The first one, since it's a negative on the outside of the radical sign, this is a reflection over the x-axis. And the second one is a horizontal shift. I keep spelling this right for some reason. And it's going to the left by 2. Okay, next one. This particular function has 3 transformations, 1, 2, and 3. The first, because you're multiplying by a number greater than 1, you have a vertical stretch by 3. The second one, you're subtracting on the inside of the function, so it's a horizontal shift. It's minus, it's going to the right by 5. And the last one, we're adding 2 on the outside. This is a vertical shift. And you're going up by 2. Okay. The next 2 problems are writing the transformations onto the function. So we have 2 things that are happening. We're going to the right by 3 units, which is a horizontal shift. We're going up by 2 units, which is a vertical shift. So to write this, we're going to write g of x is equal to, there's actually two answers that would both be fine. I'm going to show you the first one. So we have the square root of x. We're going to do to the right by 3 units means minus 3, and up by 2 units means plus 2. The other way you could write it is as a function of the f function. So if you did f of x minus 3 and then plus 2, this would be the same thing. Either one would be fine, whichever one works best for you. Number 18. Same idea. This time we have 3 different transformations. We're reflected over the x-axis. We're translated to the left by 9 and down by 7. So I'm going to show you both versions. We have k of x is equal to the square root of x. Since we're going to the left, we're going to do plus 9. We're going down, we're doing minus 7. On the reflection over the x-axis means there's a negative sign out in front. If you want to do the function notation version, you have f of x plus 9 minus 7 with a negative sign out in front. Either one of those would be fine. It's, again, whichever one works best for you. Okay, rewriting expressions with rational exponents. So the first one, this 16 has a 1 as an exponent, and the 4 on the radical sign will become the denominator of your fractional exponent. So we have 16 to the first 1 over 4, a to the 6 over 4, b to the 8 over 4. You do not need to reduce the fractions. You can leave them just the way they are. And that's it. The next one, this radical sign is a square root. It's got a 2 there that's just not written. And the 9 has a 1 as an exponent. So this becomes 9 to the 1 over 2 power and v to the 5 over 2. And that's your answer. The next 2 questions are basically doing the reverse of what we just did. You can see that there are 3's on the denominator, which means you have a cube root. You have a to the first. You don't need to write the 1, but you can if you want. B to the 4th, and c to the 5th. That's the answer. Again, we have a 2 as our denominator, which means we have a square root. You can put a 2 up in the corner above that little check mark of your radical sign, but you don't need to. It's assumed it's a 2 if it's not written. X to the first, you can write the 1. You don't have to. Y to the 5th, z to the 3rd. And that's it. Okay, for the next bunch of questions, we're going to be solving radical equations. Okay, first step, to solve this, I have to subtract 6. The square root of x minus 1 equals negative 1. Now this is a very important question. I'm going to highlight it with stars. This is the one instance where you should check your answer, Because if you were to solve this, the answer wouldn't work because a radical sign, or radical, cannot equal a negative number. Okay? These will not equal. So even if we solve this, and I'll continue solving it just to show you, if we squared both sides, the squared and squared would go away. We get x minus 1 equals negative 1 squared would be positive 1. If I added 1 to both sides, I get x equals 2. Now if I put this into the equation, I will never get my answer. 2 minus 1 is 1. The square root of 1 is 1, and 1 plus 6 is not 5, it's 7. So this does not work, okay? This would be a no solution. Now I could have stopped, that's ugly. I could have stopped right here when I got to this spot. Oops, let's not do that. When I got to the, where am I going to put it? The square root of x minus 1 equals negative number. I could have stopped right here because I know that a square root can never equal a negative answer, so that's why I could put a no solution. Okay? Important piece for this problem. All right, let's move on to 22. Here, I got to get the square root, the radical sign by itself first, and the first thing I have to do is subtract 16. Okay, so I'll get 2 cube root of x equals negative 16. I'm going to divide both sides by 2 so I can get the cube root by itself. So the cube root of x equals negative 8. Now you might be thinking this is just like the last problem, this is no solution, but that's not the case. Okay, the last problem we had was a square root, and a square root or an even degree, or an even radical can never equal a negative number, but an odd degree radical can. Okay, so if I were to cube both sides of this, I'm going to need a calculator to do that, because I don't know negative 8 to the third. The cube root and the cube will go away. I'd have x equals, I have negative 8, I'm going to put in parentheses, negative 8 to the third power gives me, there we go, negative 512. Now if I were to put that back into my equation and simplify it, I would do, let's see if I can find this thing in here. I bet it's under here. If I hit second math, oh no, if I hit math, there we go. The cube root of number is number 4. I'll put negative 512. I get that. I'll multiply that by 2. And I'll add 16, which should give me, what the heck? That was weird. Let's try that again. Negative 512 times 2 plus 16 . That's really weird. All right, just accept the fact that 16 minus 16 is 0, and that's what we get. I don't know what's going on with this calculator, so let's figure this out later. All right, anyway. That does work. Let's go back here. Box that out. That is correct. All right, now for some just regular square roots. All right, before we can square both sides of this, we have to divide both sides by 4. So 8 divided by 4 is 2. And then we have the square root of x minus 6 left over. Now that the square root sign is by itself, we can square both sides. So the square root and square root would cancel out. X minus 6 is equal to 2 squared, which is 4. We can add 6 to both sides. So x equals 10. All right, that would work. 10 minus 6 is 4. The square root of 4 is 2. And 4 times 2 is 8. So that works out. Next. In this case, before we can square both sides to get rid of the square root sign, we have to subtract the 2. So we'll get the square root of x equals x minus 2. Now we do have to square both sides. So the square root and square root would go away. So we have x is equal to, and now we have to multiply x minus 2 times itself. So x minus 2 times x minus 2. And we multiply that out using the rainbow method, we will get x squared minus 4x plus 4. Now to set this equal to 0, I'm going to move the x on the left and subtract it to the right. So I get x squared minus 5x plus 4 equals 0. This is factorable. Two numbers that multiply to be positive 4 but add up to be negative 5 would be negative 4 and negative 1. Negative 4 times negative 1 is positive 4, and negative 4 minus 1 is negative 5. If I set both of those factors equal to 0 and solve, I'd get x equals positive 4 and x equals positive 1. Now I do have to check these answers because the x is on the outside of the radical sign. It's very important. So I put 4 in first for x. The square root of 4 is 2, and 2 plus 2 is 4, and that's what the other side equals. So it looks like this. The square root of 4 is 2, plus 2 is equal to 4, and that checks out. So 4 is working. The other one, the square root of 1 plus 2 equals 1. Well, the square root of 1 is 1, and 1 plus 2 is not 1, it's 3. That doesn't work. So 1 is not an answer, but 4 is. So it's important to check your answers. Here we go, number 25. Again, before we can square both sides, we have to add the x to get it over to the other side. So we have x minus 1 is equal to the square root of x plus 1. Now we can square both sides. If I square x minus 1, I would get x squared minus 2x plus 1 equals x plus 1 on the right-hand side when the square root and the square root cancel each other out. Again, I want to get all my terms on the one side of the equation. I want to move everything to the left, so I'm going to subtract x and 1. I will get x squared minus 3x, and then the 1s will cancel each other out, and I'll just get 0. Now this is still factorable, all right, but it's not factorable the same way we did the last problem. All right, this has a greatest common factor. There are two x's there's one x in each problem, or each term of a problem. We can take an x out, we're left with x minus 3 left over. Now if I take both of those factors and set them both equal to 0, I will have x equaling to 0 and to positive 3. Now I do have to check these answers. Now I'm going to check them in the simpler version of x minus 1 equals the square root of x plus 1, all right, where I got it from here. Okay, so I put 0 in first. So I have 0 minus 1 equals the square root of 0 plus 1. Well, that gives me 1 on the right-hand side, and the square root of 1 is 1. And negative 1 does not equal 1, so that's not true. So 0 is not an answer. Let's try the next one. 3 minus 1 equals the square root of 3 plus 1. Well, 3 minus 1 is 2. 3 plus 1 is 4, and the square root of 4 is 2. So that does work. So 0 does not work, but 3 does. Finally, this version, we have 26. Now the square root sign, the radical sign is already by itself, so we can just go ahead and square both sides. So we have 9 is equal to 2x. Divide both sides by 2, and x equals 9 over 2. Okay, if we put it in there, 2 times 9 over 2 is 9. The square root of 9 is 3, and that does work. And that's it. All right, Kayla can wash a car in 13 minutes. So we have Kayla. She can wash one car in 13 minutes. Kristen can wash the same car in 14 minutes. Find out how long it would take them if they worked together to wash 3 cars. So here we go. Okay, I'm going to put up the calculator again. Hopefully it doesn't do weird stuff again. Okay, so we want 13, 14, and x are our denominators. So we have to 14x. This is going to be a 13x. It's going to be 13 times 14. Okay, now that we've got all the numerators and the denominators to be common, we can get rid of the denominator. So we'll have 14x plus 13x equals 3 times 13 times 14. Gives us 546. There we go. So if we combine the two like terms, we got 27x equals 546 divided by 27. So we got x is equal to 20.2 hours. Oh, minutes. Sorry. We're doing minutes. That's our answer. All right. Next question. Working alone, it takes Maria 12 hours to pick 40 bushels of apples. So we have Maria. She's doing 40 bushels of apples in 12 hours. Shanice can pick 60 bushels of apples in 9 hours. They work together. How long would it take to pick 70 bushels? So 9 and 12. So we have 9x here. We have 12x here. We have 12 times 9. Okay. So 9 times 40 is 360x plus 12 times 60 is 720x equals 70 times 12 times 9 equals 7,560. Now there actually is a quicker way to do this. 12 and 9 both share a common multiple of, common multiple of 36. So you could just multiply 12 by 3 and 9 by 4 to get 36. All right, or you could just do it this way. It doesn't make a difference. You'll get the same answer at the end. It's just you'll use smaller numbers than we have right here. So if we continue, we got 360 plus 720 gives me 1,080x equals 7560. 7560 divided by 1080 equals 7. 7 hours. There we go. All right. C can mop the floor. One floor in 45 minutes. Star can map the same floor in 30 minutes. The star starts working 10 minutes and is then joined by C. How long would it take them, the two working together, to finish mopping the floor? So it's one floor over X. Now, here's the issue with this particular problem. All right, we have Star working for 10 minutes by herself. Okay, so we have to take Star's 10 minutes and subtract it from the total. Okay, so how do we do this? Okay, we take Star's time of 1 over 30 minutes, one floor in 30 minutes, and we multiply it by how long she was working, which was 10, which gives us 10 over 30, which is 1/3. Okay, so she did 1/3 of the job before the other girl started. So we're going to take our total job, which is in this case the 1, and subtract how much Star did. She did 1/3 of the job, which gives us 2/3 left over. So 1 minus 1/3 is 2/3. If you don't believe me, 1 minus 1/3 is that, which gives us 2/3. So how we rewrite this question is we're going to take away, we're going to take away this for right now, and we're going to put in 2 over 3x, so 2/3. Okay, so that becomes our new fraction for what's got to be done. Okay, now, as I mentioned before in the last problem, you can find a more common denominator. So rather than multiplying all this stuff by 45, 30, and its really big numbers, let's find out a common term. Well, 45, 30, and 3 all go into 90. Okay, so if I multiply this by 2x, 2 times 45 is 90. If I multiply this by 3x, 3 times 30 is 90. And if I multiply 3 times 30, all right, 30 times 3 is 90. So I will have 2x plus 3x equals 60. If I add 2 and 3 together, I get 5x equals 60. Divide both sides by 5, and x will equal 12. Oh, hold on. What are we doing? Minutes. There we go. And that's how you do it. Last one of these. Dana can detail a car in 28 minutes. Paige can do it. Oops. In 14 minutes. Sarah can do one car in 21 minutes. If they all work together, how long would it detail a total of 13 cars? All right. So again, this is a indication of what do they all fit into, so we don't have to make such big numbers. Let's see. This is 4 and 7. This is 2 times 7. And this is 3 times 7. So if we go to let's see. What could we do? We could do 12. Okay, so if I wanted to make all these 12 times 7, and multiply this by 3 and x, multiply this by 6 and x, and multiply this by 4 and x. Okay, and if I want to make 12 times 7, so if I made this 3, 6, and 4, they'd all equal the same thing in the bottoms. So 12 times 7 would be 84. So I'm going to multiply the top here by 84. Okay, how that works again is I find a common number. All these have 7, so I can get rid of that. So I want to make sure I get all the other numbers to be the same. All these are the same number now. They're 12, so I multiplied what was missing. So 3, the 6, and the 4. And then I multiplied 12 times 7, which is missing in the denominator of my answer, the 13 over x, which is 84. So now I have 3x plus 6x plus 4x equals 13 times 84, gives me 1,092. There we go. All right, if I add the 3x values terms together, I'm going to get 13x equals 1092. 1092 divided by 13 is 84. Oh, that's crazy. All right, and that is minutes. Okie dokie. All right, now we're going to get rid of this calculator and go to Desmos. Now you can do all the calculations on Desmos anyway. I like the other calculator better just because it's just regular calculations. All right, so charter company will provide a fare for $400 per passenger for 50 or fewer passengers. For each passenger in excess of 50, the fare is decreased by $2 per person. So we have all this stuff, but the nice thing is you are given the equation to use right there. Okay, so all you have to do, since you don't have to find the equation, is use that equation in Desmos. So we have 400 minus 2x times 50 plus 1x minus 21,000. So there is our graph. Let's shrink this down. All right, so there's our point. So it says, what should the number of passengers over 50, what should be the number of passengers over 50 to maximize the charter's profit? Well, X would be the 75. Okay, so we should have so X should be 75, so 75 passengers. Okay, now what fare should the company charge to maximize their profits? So we're going to put 75 in for the part where it's profit. Okay, so the fare is $400, but it's being decreased by 2. So this is the fare. Okay, so we're going to do 400 minus 2 times 75. All right, so we can do that in here. 400 minus 2 times 75, which is $250. Okay, there we go. The next one, same idea. You're given all this stuff, but you're given the equation to use. So we're going to plug that back in, okay, to our Desmos. So we have 31 plus 2x. We have 40 minus x minus 540. Okay, so we have that graph now. So we've got to find out where the graph is. There it is. Oh, went the wrong direction. Okay. What should the price per day what should be the price per day to maximize the rental cars agency's profit? Okay, so we want to know the price. The price is $31. So this is the price right here. Oops. So we're looking at the X term, which is 12.25. We got to round down to 12. So we're going to do 31 plus 2 times 12. If we figure this out, 31 plus 2 times 12 is $55. Okay. And how many cars does the agency need to rent to maximize the profits? Okay, so we're doing, that's this part of our equation, the 40 minus 1x. So we're going to do 40 minus 1 times 12. So 40, oops, do a different equation. 40 minus 12 would be 28. There you go. And that's it. That is the whole review sheet. Good luck on the test.